Okay, so polynomials and rational inequalities. For my college algebra, this might look a little different than your notes, but the examples are the same, just a little more information has been added to these notes here. Okay, so solve each polynomial inequality, graph the solution on the real number line, and then we want to express our answer in interval notation. So that'll be the main thing I'll be looking for is the interval notation. The number line is kind of there to help you. So here's the hint on basically how to solve these. We're going to start out with parabolas, but really these are all going to be kind of solved in a very similar way. So the hint here is that when a graph crosses the x-axis, so let me pull the picture up. When a graph crosses the x-axis, the y value of the function is going to change from positive to negative or negative to positive. So as you can see right here, you can see my graph, the y value is positive until I cross the x-axis. Now my y values are negative, and then once I cross the x-axis again, my y values go back to being positive. So whenever you cross the x-axis, there's a sign change in your y value, okay? So the way we're going to do this is we're basically going to find our x-intercepts for all these equations we're going to look at, okay? And then we're going to test values within the subintervals to see if they satisfy the inequality. So let's go ahead. I'm going to scroll down, and this first one, they give us a picture. So this one's pretty easy to figure out, but they'll get a little bit more challenging in a minute because we won't have the picture there. So you can see the equation they gave us: x squared minus 7x plus 10 is greater than 0. So what they're trying to figure out is what x values, when you plug it in, will result in something greater than 0. And what they mean by that is y. They want to figure out basically, this is equivalent to y. Basically, y is equal to this equation. But basically, we want to know when y is going to be greater than 0. That's basically the question here. When is y greater than 0? And so once again, from the picture, it's pretty easy to tell that it's these two intervals above the x-axis, okay? But as I was saying, we're not always going to have a picture to go with it. And so really the best way to solve these is just to factor the equation that you're given, find the x-intercepts, and then test points between and beyond those key points. So if you look right here, let's see, this would factor, let's see, this factor, let's see, multiply, let's see, so that would be a -5 and -2. So basically those x-intercepts are at 5 and 2. Okay, and obviously you can already see that on the graph. So what we're going to do with this number line over here, oops, there we go. So with the number line right here, I'm going to go ahead and put 2, I'm going to put 5. And so we want to figure out, what values will satisfy my given equation up there. So we're going to test some points. So let's see, let's test. A very easy one to test would be 0. 0 would be in this interval. Then we'll test something over here. We'll keep it easy. We could do 3, 4, something between 2 and 5. And then we need to test something beyond 5, like 6. So what we're going to do is we're going to test something within the interval. And if it works for that number, it's going to work for all the numbers inside this interval. Okay, so we have 3 different intervals we're going to test. Something to point out is that we're looking for when y is greater than 0, or basically our results are going to be greater than 0. So 0 doesn't work. Okay, so if we get 0, that's not a good answer. So what that means is that 2 and 5 are actually not going to be included as part of my solution set. It's basically impossible to be part of my solution set because if I plug those in, I get 0, which would give me a false. That would give me a false statement on my original equation up here. If I plug in 2, I'd get 0 is greater than 0, which would be false. Same thing with 5. If I plug in 5, I'd get a false statement. Sometimes those will actually be included, okay? It depends on the inequality sign that we're using at the time, okay? So anyways, we'll see plenty of examples where they are included later. Okay, so let's go ahead and test 0. So let's see, I'm going to plug in 0 to my original equation. So let's see, I want to test if 0 squared minus 7 times 0 plus 10, is that greater than 0? So this is a question we're asking ourselves. And so 0 squared is 0 minus 7 times 0 is 0 plus 10 is greater than 0. So what we're ending up with is 10 is greater than 0, which is true. So since that came back as true, we're going to go ahead and shade this interval right there because it came back true, so we get to include it. Okay? So now we'll do the same thing with the number 3 and the number 6. If it comes back true, you shade that interval. If it doesn't, then we don't. All right, so here we're going to get 3 squared minus 7 times 3 plus 10. We want to know, is that greater than 0? So this is a question. So 3 squared is 9 minus 21 plus 10 greater than 0. And so let's see, 9, take away 21, let's see, that's negative 12. Negative 12 plus 10 is negative 2. So we end up with negative 2 is greater than 0. Scroll down a little bit, which is going to give us a false. So do not shade here. Do not shade here. That's not part of my solution. Okay? And then now we'll try the 6. So let's see, we're going to have 6 squared minus 7 times 6 plus 10. And we want to know, is that greater than 0? All right, so 6 squared is 36. Negative 7 times 6 is going to be a minus 42, and then we get a plus 10. And so let's see, 36 take away 42, that's negative 6. Negative 6 plus 10 comes out to a positive 4. 4 is greater than 0, that is true. So now we're going to shade that region right there, okay? So now we need to convert this into our interval notation. So that first interval is going to be from negative infinity to 2, but not including 2. Union, then from here we're going to go from 6 to infinity. And that's our answer right there. Okay, so I've got a couple more of these, but as we move forward, we won't have the graph of it. But, you know, you could have probably answered this one pretty easily without doing anything, just looking at where is y greater than 0. Okay? All right. Okay, so here's number 6. So we want to start by factoring this. So let's see. Let's see, there should be a minus 3 and a minus 1. That looks right, okay? So we're looking at our solutions as being 3 and 1, okay? That would actually make the equation 0. So those come back as false answers, but those are key points though. So let's see, 1, and we'll put 3 right there. Okay, so those are not going to be included. So we'll do open circles. Oops. Okay, so those are open circles, and now we got to pick some points to test. So once again, you know, 0 would be an easy one to test. Oops. Oops. All right. So another easy one to test would probably be like, you know, the number 2. Then we could try the number 4. All right. So, so let's see if we plug in 0. Let's see what happens here. So let's see. We're going to have 0 squared minus 4 times 0 plus 3. Is that less than 0? Is that less than 0? So we're wondering, And so if you do the algebra, you're basically going to get 3 is less than 0, which that comes back as false. So that's not going to work for us. 0 is not a good one. Okay. Now we can try 2. So let's see. 2 squared minus 4 times 2 plus 3, is that less than 0? And so let's see, we get 4 minus 8 plus 3 less than 0. 4 take away 8. Let's see, we got negative 4. Negative 4 plus 3 is negative 1. Is negative 1 less than 0? That comes back as true. So we're going to shade between those two key points right there. Okay. All right, I got one more over here. And by the way, if you wanted to, you could plug where I'm testing it. You can actually test it in the factored one. And honestly, that probably makes life a little bit easier. So you can just plug them in here and just kind of do the math in your head. I'll show my work on this one just so y'all can see what I'm talking about. But as we move forward, I'm probably actually going to do it this way. It's a little bit nicer. All right, so we're going to plug in 4. So what I'd have is 4 minus 3 times 4 minus 1. We want to know if that's less than 0. So 4 take away 3 is 1. 4 take away 1 is 3. Is that less than 0? 1 times 3 is 3. 3 is less than 0. False. So we're not going to shade that area. So anyways, hopefully you saw what I did there. I was just plugging it into the factored form, and it doesn't matter. You can plug it into either one. But as we move forward, we're going to start getting some higher powers and stuff. And so probably going to be easier to plug it into that factored form to test it. So this interval is going from 1 to 3. So from 1 to 3. And so we want to use parentheses because we're not counting the endpoints. All right, I think I got maybe 1 or 2 more of these. Okay, so this one just needs to get cleaned up a little bit. We want to kind of make it look like the others. And so, oops, what happened there? Okay. So what we'll do here is subtract an x from both sides and add it to both sides. So let's see, we end up with x squared minus 2x. And then negative 5 plus 2, let's see, that'll be a minus 3. And we want to know when that's greater than or equal to 0. So this time we actually have the equals to part of our inequality with us on this particular example. And so we'll go ahead and factor this. And so let's see, it should be a minus 3 and a plus 1. Our solution set is 3 and negative 1. Now, in this particular case, those are actually good answers, because if you plug them in, it would make it equal to 0 in our inequality state. So we want to be greater than or equal to. So when we put this on the number line, so let's see, we'll put negative 1 here, we'll put 3 here. We'll actually get to go ahead and include those points. So those are definitely going to be part of my solution set. So I'm going to go ahead and color those in. And now it's time to figure out these subintervals. And so I have 3 subintervals. And so we need to test something for each one of these subintervals. So we'll try, like right here, we'll try like negative 2. 0 would be an easy one. And then we can try 4. Okay, you can try other numbers if you want, as long as they're in the interval. But those seem to be the easiest ones to try out. Okay, so when we test negative 2, like I said, it might be easier just to plug it into here and test it into this one. We plug it in here and here. And really, you should just be able to do the math in your head. So negative 2 take away 3, that would give us negative 5 times, and if you plug in negative 2 right here, that would be a negative 1. We want to know if that's greater than or equal to 0. Well, negative times a negative is positive, and that is, 5 is greater than or equal to 0, so that's going to be true. So we'll go ahead and shade that way. There you go. Next one, we're going to try 0. So once again, you plug it in for x. You could plug it into the, well, I wouldn't want to plug it into the original. That'd be pretty messy. So we're going to plug it into this factored form. And so you should end up with -3 times 1. Is that greater than or equal to 0? Well, you get -3 is greater than or equal to 0. That comes back false. We don't want to shade here. We don't shade here. Now we'll try the 4. So you plug the 4 in. And so you get 1 times 5. Is that greater than or equal to 0? Well, you get 5 that's greater than or equal to 0. That comes back true. Now we'll go ahead and shade here. And so our interval is going to be from -infinity to -1. This time we'll bracket that -1 in. Union. Then here we're going to bracket the 3 in and go to infinity, positive infinity. And there we go. Okay, so I have one more like this. And then we'll look at some higher ordered polynomials in a minute. Okay. So once again, you'll want to go ahead and set it equal to 0. Oops. Put that -1 first. Okay. -1 less than or equal to 0. We factor this into x plus 1. X minus 1 is less than or equal to 0. Okay, so your solutions here are -1, +1. And actually, those both work because if you plug it in, it will cause the equation to be 0, which would be a true statement, less than or equal to 0. So let's see, we got a -1, +1. And so we are going to go ahead and include those 2 key points. Okay, and now we got a test. So let's see, we're going to go ahead and test like -2 could be good, 0 is good, and then +2. All right, once again, it's probably going to be the easiest way to approach this. Is going to be to plug it into the factored form. So if you plug in -2 here, you're going to get -1 times -3. So -1 times -3, is that less than or equal to 0? Well, negative times a negative is positive. So 3 is less than or equal to 0. That is false. So we don't want to shade that. Okay. And then here we're going to plug in 0. And so that's just going to end up with 1 times -1. Less than or equal to 0. -1 is less than or equal to 0. That one comes back as true. So this one we do want to shade that interval right there. Okay. And then the last one we plug in 2. So you're going to get 3 times, what is that, 1 less than or equal to 0. So you get 3 is less than or equal to 0. False. That one's false, so we don't shade it. And so our actual solution interval, though, is going to be bracket -1 to +1. And that's it for our quadratic polynomials. So the next part will be, we'll go to some higher powers, but it's going to be done in a very similar way.